Sieve of Eratosthenes. So using this method, we would find the number of prime numbers that are present in a range uh, 1 up till n. So using this method, we can find all the prime numbers that are present in a range. So what we would do is, initially we would make one array prime of size n plus 1, and we would make all the elements at true. Now further, we would start a loop from 2 up till n. So here what we would be do is, we would each index of this prime array would represent a number. So let's say an index I, that is 1, that is 0, then it represent the number 0. If I equal to 7, then it represent the number 7. So what we would do is, each so initially each index is true, means we mark each number as a prime number. Further, we would loop from 2 to n, because 0 and 1 are 0 and 1 multiples are all the numbers. Let's say 0, 1, 2. So 0 and 1 has all the numbers as in multiples, so we won't consider 0 and 1, and we would start the loop from 2 up till n. And let's say if 2 is true, that means if 2 is prime number, what we would do is, we would make multiples of 2, that is 4, 6, 8, 10, 12 as false, because these numbers can never be a prime number, as they already have one multiple other than 1 and that is 2. Similarly for 3, if 3 is a prime number, we would make it multiples like 6, 9, 12, 15, 18 as false, because they already have one another factor 3 that make them not prime number. So I hope you know the definition of a prime number. So a prime number n is a number that has only two factors, that is 1 and the number itself. But here let's say if n is equal to 6, then n has more factors. Let's say because one is order factor, n itself is factor, but the number 6 has also 2 as a factor, 6 has its factor, so it is not a prime number. So similarly, such thing we are doing here with the help of this array. So let's understand this with an example. So here, if you want to find all the prime numbers present in the range of 0 up till let's say 13, then what we would do, we would first create one array of size 14, and we will mark all the numbers as true. So initially 0 to 13, all the numbers as marked as true. Then both 0 and 1 are marked as false, because both these numbers cannot be a prime number. Then we will start a loop from 2 up till 13. So let's say now I is equal to 2. So we'll make multiples of 2 as false, because they cannot be prime, as we discussed earlier. So multiples of 2 are 4, then 6, then 8, then 10, then 12. So these numbers are marked as false, because they can never be a prime number. Now for I equal to 3, because 3 is a prime number still, because answer of now I goes to 3, and it's true, then we would mark multiples of 3 as false. Now multiples of 3 are marked as false. Let's say 6, then 9, then 12. If 15 would be there, then it would be also marked as false. Now further, we go to 4. 4 is false, yeah, so we won't track for 4. Then 5 is false, 5 is true, yeah, so it is true. So it's multiple 10 is, we would make it false, it's already false. Then 6 is already false, we won't traverse for 6. Then 7 is true now. Now 7's next multiple is 14. 14 is not present, so we would stop. And now for all the numbers, let's say 8, 9, 10, we won't traverse, because they are already false. 11 is true. Its next number 22 is not in the array, so we won't traverse for them. Then 13 to the 26 and 1 is not there, so we won't traverse. So you might be thinking that so one more optimization we can do here. So instead of going for all the checking for all the numbers if it's true or not, we would stop when I square is less than equal to n. That is, if let's say here n was 13. So when we would stop is when let's say I is equals to 4, then 4 square is 16. 16 is greater than 13, then we would stop. This is because that all the numbers before 4, let's say that are 2 and 3, that multiples are already marked as false. Now no such number would be present whose multiples is there in this range. In this range 1 to 13, no numbers would be present whose multiples is there. So like after 2 and 3, another number we came to know that let's say 5 is a prime number, but in multiples, let's say 10 and 15. 10 is already marked as true. Sorry, 10 is already marked as false. Now 15 is not present in the range. So traversing for multiples of 15, whose because 25, that is a 5 square, is already greater than 13 and it won't be present. So the multiples of this 5 won't be present. So we don't need to check it. Similarly, for I is equal to 7. So now 7 square is 49. Now 49 is already greater than 13 and it won't be present in our array 1 to 13 in our range. So we won't traverse for 7. So this condition will stop whenever I square is greater than n. So we would stop traversing for the time. I hope my point is clear that we would stop here whenever we hit I square is greater than n. So we will traverse only for these two numbers 2 and 3 because we are starting from 2 up till I square is less, up till what I square is less than equal to n. Whenever we hit any such condition, we would simply break. So this is how we would loop to check for the prime numbers in the given range. Okay, let's now go. Let's first make. Let's first declare one answer or one integer vector, all prime. Let us take one input n, c in n. That means we are finding all the numbers in the range 1 to n, and then we would make resize this vector to n plus 1 and we would fill all the values as true, as we have discussed in our in our explanation part. Then we would call for all the function, then we would call each prime function, or let's say name is find prime in the range 1 to n. So I have passed one vector, so I have passed one parameter n. Now let me code this function void find prime int n. So firstly we would make I equal prime of all prime of 0 as false because 0 is not a prime number. Similarly 1 is not a prime number, so I would mark it false as well. For now I equals to 2 up till I square is less than n, less than equal to n. What we would do is, if that number is a prime number, if all prime of I equals to true, then we would mark the multiples of I as false. First of all, j equals to I square, j is less than equals to n, j plus equals to I. Instead 2 into j, okay, I would mark all prime of j equals to false because that is not a prime number. Let's say if I is equal to 3, then 6, 9, then 12, 15, they are not a prime number. So I mark all these numbers as prime. And okay, so this is the simple logic of this sieve of Eratosthenes. And if you want to, I want to print the all the numbers, then I would do that. For it I equals to 0, I less than equals to n, I plus plus, and if all prime of I equals to true, then I would print I. Okay, so that's all for the code here. Now let me give some input. Let's 19. So all the prime numbers present in the range 1 to 19 are 2, 3, 5, 7, 11, 13, 17, 19. So I hope you got the solution of finding the prime numbers in a given range from 1 to n using this sieve of Eratosthenes. So that's all for this solution. So that's all for this video. I hope you guys liked the video, and if you have any doubts, let me know in the comment section below. Make sure you like the video and subscribe to our channel. Thank you.